Hello, welcome to the second part of our third lesson in our fourth unit, trigonometry, in our grade 11 University College math class. The second half of this lesson has us looking at angles of depression. So, similar to angles of elevation, an angle of depression has, and again I've made a drawing of it here so you can kind of see it. It assumes that your eye, which I've drawn right here, is looking out horizontal and is in fact parallel to the ground. Now, is this an assumption? Yep, for sure it is. However, that is an okay assumption to make in questions like this. Assuming that your eye line is running parallel to the ground, so it's essentially a horizontal line, the angle of depression is from that horizontal downwards. So as an angle of elevation is horizontal then upwards, an angle of depression is horizontal and then downwards. So keeping that in mind, just one final assumption to make is that we have these 90-degree corners here. Again, a safe assumption to make. I also want to point out that when you're working with angles of depression, the inclination, especially because you're given the angle of depression, is to use sort of an inverted triangle as the triangle that you're going to be working with and figuring out. But I want to point out that because we're dealing with two parallel lines, there is another equally usable triangle that is in a more familiar triangle position, which is having sort of the base on the bottom. And because these two lines are parallel, the ground and the sight line, and because it is cut by a transversal, which is a straight line that cuts across the two parallel lines, it means that, and this is actually starting to look pretty messy, so let me erase some of this stuff here and tidy it up a bit. The important takeaway is that the angle of depression down to, in this case the tree, is similar or is identical to the angle of elevation from the thing you're looking at looking back up at you, if that kind of makes sense. Okay, so let's move down to an example of how to use the angle of depression to figure out either a side length or an angle. So here's our question. And I know that many of you will struggle to draw a horse as nice as mine in this example. I'm going to zoom in on it because I feel that celebrating artistry is important, and obviously I spent many years perfecting the craft of drawing horses and people for that matter. So again, enjoy this. I can only imagine that yours will be maybe not quite as good as mine, but don't beat yourself up about it. There's lots of time to become better at drawing horses in your life. Okay, question reads, Sarah is on horseback riding towards the stable when her horse stops to graze. From a height of 2.6 meters, Sarah's sightline makes an angle of depression of 6 degrees to the threshold of the stable. How far are they from the stable? Okay, there's my drawing. I kind of used all the space in this when I sketched it. You don't have to necessarily make it quite so large. But I do want to point out that we have some particular pieces of information that we should get on this triangle before we do our little shout out triangle. So what do we know? We know that Sarah's sight line looking down, so from horizontal downwards to the stable, is 6 degrees, and that makes sense to make that my reference angle. We also know that Sarah is 2.6 meters above the ground, so if we can imagine that this distance here is 2.6 meters above the ground. I want to point out that of course that would be a 90 degrees with the ground, and we actually have 2.6 all the way over here on the other side as well, given that we've essentially just created two triangles that are kind of mirrors of each other. We have this original sort of inverted triangle, but we also have this maybe easier to use version of the same triangle with the base at the bottom. And as I said above, as a mirror, this will also then be 6 degrees, the angle of elevation from the floor of the stable up to Sarah's eye. So for my preference, I like to have the base of my triangle on the ground, so the shout out triangle that I'm going to use is going to be the one I've just highlighted in green, the bottom one. So let's start in on that. What do we know about this thing? Well, we know that this was 6 degrees, and we know that this was 2.6 meters, and we want to find Sarah's distance from her horse to the stable. So let's start in with this. I'm going to start by making a reference angle. I'm going to keep that as 6 degrees. And I'm going to label all 3 sides of my triangle. I would encourage you here to pause and label the triangle on your own and then come back and see if you've done it correctly. So why don't we do that now? Okay, you're back. This side over here is the hypotenuse across from my right angle. This side here is my opposite, and this side at the bottom is my adjacent. So as before, I'm going to model a way to figure out which trig ratio to use, and it starts by just writing out SOHCAHTOA. And I'm looking for what information I have and what information I want. So in this triangle, the information that I have is the opposite side. So I'm going to put some check marks above the O's for opposite, which means we're not going to be using cosine in this question. Now I'm asking myself, what side is it that I want? And I want the adjacent, which means that I'll be using the tangent ratio and not sine. So let's set this up now. We have the tangent of 6 degrees is equal to my opposite, which is 2.6, over my adjacent, which is unknown. And now I'm going to go about solving for x. Tan 6 degrees, of course, is a number, and I'm going to write it over 1, and now I'm going to cross multiply in order to isolate my variable. So I'm going to have, when I'm done cross multiplying, x times tan 6 degrees is equal to 2.6. Now x is not isolated yet. In order to isolate it, I need to divide both sides by tan 6 degrees, because x is currently being multiplied by tan 6 degrees, and the way we undo that is to divide by tan 6 degrees on both sides. Once I do that, I do have my x isolated, and I'm going to just type this into my calculator. So I have 2.6 divided by the tan of 6 degrees, and that's going to equal 24.7 meters approximately. And there we have it. So we need to write a little therefore statement on there. So therefore, Sarah is 24.7 meters from the stable. 24.7 meters from the stable. So again, I'll just sort of zoom out a little bit so that you can see my magnificent horse again, and also see all the calculations on your screen. So this is the end of our lesson on angles of elevation and angles of depression. Really, the big takeaway is just being able to distinguish not even so much angles of elevation. I think a lot of students, for whatever reason, find it easy to imagine looking up at stuff, and that the angle of elevation is from horizontal to up. I think angle of depression is the harder one for students, where we have to consider that it's the horizontal angle, or the horizontal line, and then going downwards to find the angle of depression. After that, it's pretty straightforward, just using our primary trig ratios to figure out unknown sides. We didn't get to do any angles in this question, but maybe in the next one. So this is the end of lesson number 3. Take a crack at that homework, and if you have any questions, as always, feel free to email me, and otherwise we'll see you in lesson number 4.